Hey, everyone. All right, I just need to set this up, and I'm good to go. Wow, this little echo is weird. OK. In all the other rooms, they started with like the general stuff. Like there's 2 emergency exits at the back. To buckle your seatbelt, clip the middle, well, whatever. Moving from relational to documents. So welcome to this talk. I'll be talking about a little bit about the challenges that I had when I started using document databases, moving away from 20-some years of using traditional SQL databases. So hopefully you'll find that to be somewhat useful. Let's start by taking a quick look at the history of databases. So back in the 60s, is kind of where they started with the first computers. And a lot of them were using punch cards and stuff like that. But they quickly realized that they needed to find a way to store that data and to persist that data. And at the time, those hard drives were very, very expensive. So in the 1970s, damn, that's smart. Cod wrote an article about how we could save some space by using this relational model where you have an ID. Anyways, you're all familiar with that. So that came in the 70s. In the 80s, SQL was pretty much the prevalent model for most databases. In the 1990s, if you're my age, you'll remember the information highway, which is kind of when the web came out. And there's more and more data was generated. In the 2000s, we were getting a lot. And in the 2010s, we started to need a database that would be web scale, right? So that's when a lot of different types of databases came out. So yeah, that's actually one of the hard drives in the 1960s. That's the IBM 305. That was 5 megabytes, and it cost $3,200 per month to rent it out. They could actually buy it for, I think it's $50,000, which is $537,000 like of today's money, which is crazy expensive for like 5 megabytes. Thankfully, things have changed a little bit. I found just a quick Google search. Now we've got like those tiny little drives, like 1 terabyte of data for $55. So that's 1,000th of the price for 200,000 times the storage space that we've got. So because we have access to all of that data space that we can store, we can start thinking about data slightly differently than what we did in the 70s or 50 years ago. Well, before I jump in this, let me introduce myself. My name is Joel. I love having huge pictures of myself on a big screen. That's the only reason why I come to Star Trek. It's also because it's a great conference. I love being here. I work as a developer advocate for MongoDB, so of course I'll be a little bit biased today. I'll talk a little bit more on the MongoDB side of things, but pretty much everything that I'm going to introduce today applies to all document databases. I am based in in Canada, so near Ottawa on the Quebec side. So that's the charming French little accent you might recognize here. And if you ever want to get in touch with me, Twitter's kind of the best way. I don't really look at Twitter, but sometimes I get a notification and I'll look at it. So it's still the best way to reach me. Mastodon, maybe, I don't know. At some point, I'll jump in. TikTok, is that what the cool kids do? I don't know. Twitter. All right, what are we going to talk about today? I'm going to talk a little bit about what are NoSQL databases, and then we'll move more specifically into document databases and how it's an evolution of relational or traditional databases. And then we'll talk about some of the modeling practices and how you can start thinking about your data differently. So of course, we need something with ChatGPT. So I've asked ChatGPT, what is a database? Please explain it to me like I'm a 5-year-old, which was actually interesting. A database is a really big toy box for information that grown-ups use to store important information. I thought that was interesting. And just like you can take out a toy from your toy box to play with, grown-ups can use a database to find information quickly and easily. And that's the important part here, or the interesting part, is that we need access to that information in a way that is quick and easy. So that's kind of what I'll try to show today. So what's a NoSQL database? There's been a lot of new ways of thinking about data in the last couple of years. So those are kind of the 4 general categories of databases that fall into the NoSQL area. So there's like the old traditional SQL, well, not necessarily old. There's a lot of very modern and cool software that is coming out nowadays. But there's like the SQL way of doing things, and then there's the NoSQL, which actually means not only SQL. Key value database is often used. Redis is a good example of that. What else? DynamoDB on AWS. So it's really a key value storage. So you put in a key, put in a value, and then you can retrieve that value based on the key that you have. So very convenient for sessions and things like that that you want to store, and you'll just have that ID and retrieve all the information associated with that. There's also wide column stores, which now I'm blanking out on the name of the most common one, but that doesn't matter. So it's kind of similar to one of those traditional databases. So you have your data stored in a row and column format, but you can have multiple rows. The schema can kind of change from one row to the other. And then we've got graph databases, which are very interesting. So very different way to think about your data. Where you're looking at a graph database, you're really looking at the relationships between the data rather than looking at the data itself. And then, of course, there's the document databases, which is what I'll be focusing on today. So document databases, well, they use a document model to store data. And what is a document model? Well, you can think of it as a JSON object. Now, when we look at MongoDB, we're not storing the data in JSON format in a plain file. Of course, we're using a standardized called BSON. So it's a binary representation of JSON. So it gives you access to more data types than just a plain JSON would do. But we oftentimes think of the data in MongoDB as being JSON because we can take a JSON object and just store it in the database. So on the right, you've got an example of such a document. So as you can see, if you've done any web stuff, like you'll recognize this as being very similar to a JSON object. In this specific example, you'll notice that some of the fields have a type. So there's like some geodata in there as well. So you've got access to all of those extended data types. So that's what a document looks like. When you compare a document database with a relational database, pretty much everything is, well, very similar. You've got databases which are the exact same thing. They're called the same thing. So a database in MySQL is the same thing as a database in MongoDB. One thing that is slightly different here when it comes to terminology, we don't call those tables, but we call them collections. So I'll be talking about collections throughout this talk. Just know that it's pretty much the same concept as a table in a traditional database. Then we've got our documents. I've shown you an example. So a document is pretty much the same thing as a row in a traditional database. It's the same thing as a row, but it could also be multiple rows. And I'll get back to that when I start to show you how to translate those relationships that we use in SQL into a document database. Then you've got the fields. Fields are just the same thing as a column. You've got indexes, just the same way as you have in SQL. You've got views. You've got transactions, all the fun stuff, and relationships. Now, relationships are where things will vary, where it will change a lot between MySQL or a SQL database and MongoDB. So relationships have multiple ways, and I have a full section on that later. So document databases, I like to think of them as an evolution of the traditional relational databases. I hear a lot of time when I talk to people and I tell them that I work at MongoDB or that I use MongoDB, people tell me that, well, they can't really use it because their data is relational, which is a good point. all data is always relational. We usually don't just store stuff and don't try to make any sort of information with it. So the data is always relational, and there is just a different way to represent those relationships. When I started at MongoDB, or when I started using MongoDB the first couple of times, that was really my biggest hurdle. I found it really hard to try to change my mindset from the relational way of thinking into the MongoDB way of thinking. So when you look at a traditional relational database, like I said, if you're like me, if you've got a little bit of gray hair, you've probably been doing that for 20 years. If I show you this web page, this will be the example that I'll be using throughout this presentation. So let's assume that this is a website that I'm about to launch. It'll be a website where people can publish their recipes. We'll have millions of users coming in to view those recipes. And I'm going to have a couple of select chefs that will prepare or author a couple of recipes once or twice a week. So if I'm using a relational database, and like I say, if you've got some gray hair, you're already looking at this and imagining all of this already in your head. Like that's the first thing I'm always doing. I'm looking at the data, I'm like normalizing everything. I got it, ready to go. It's kind of a reflex. And when we look at our document databases, we have to change that a little bit. We have to think of things slightly differently. Now, notice how the data here has nothing to do with the page that I've just shown you right here. So everything is kind of split, but on this page, everything is coming together. So the data was really modeled based on the database itself. So I had to use those rules to store the information as I should in a SQL database. However, when I'm looking at a document database, we have to design a schema that works for your application, or even better for you as a software developer. That's one of the things that I find the most useful about using document databases now that I'm a little bit more used to it. So again, if we look at this website, we know that it's going to be a website that there's going to be a lot of people coming in, there's going to be a lot of reads. So how can we start modeling the data to represent the data that we've got on this application? So the first thing, if we look at the top here, we've got just general information about the recipe, so the name, the number of servings, a couple of things that are too small on my screen to read. So the relational database, we would store that in a table, have a couple of columns for each one of those fields, and in our document database, we'll do the same type of thing. So we'll have this JSON-like object that will have key value pairs to represent the same values. OK, what else do I have in here? The next thing that I have, let's look at the bottom part. So the part that says instructions, which just tells me all the instructions for to proceed for my recipe. Again, if we look at our relational database, we've got this other table. And in that table, there will be your recipe ID. So I'll be able to make the relation between the recipe and the instructions that are for that specific recipe. Now, that information is always associated with that recipe. It'll never be reused anywhere. The instructions are very specific to a very specific recipe. So what we can do in the case of our document database is that we can just use an array. We'll just put an array of strings, and everything is embedded into that same document. So already you're seeing that we don't have to do that join anymore. We don't have to fetch the data from the two tables, merge them into one big object. We're just putting everything that we need into that single object. All right, so what about the part in the middle? We've got the ingredients, and for the ingredients part, again, if we think in terms of relational, we're putting the ingredients in their own table. We're creating this join table that has a bunch of numbers. Actually, we should probably put measurements in their own table as well, so we can reuse that in order to save disk space, right? So we've got this huge table that means absolutely nothing if you're trying to look. And if you've ever done like me and you open up phpMyAdmin and you're trying to figure out what's going on, like it's just, you can't make any sense of that data. So that can be a bit of an issue. When we look at our document database, what we'll do in this case is that we'll, again, just embed all of that information into that recipe object that we have. So at the bottom right here, I've got my list of ingredients, and you'll notice that I've got all of the ingredients with the associated measurements and everything that is needed there. So again, that's very useful. I can just fetch all of that big object, and I've got all the information that I need to display on my page. Now, of course, the first time I've used a document database, it's like, I'm duplicating all of my data. How can I ensure consistency? And that was just driving me insane. I was like, ugh. It just bugged me so much to see that information repeated and duplicated across all of those different objects. So here's how you can fix that. If you think of when you're using your SQL database, what you'll do to populate those dropdowns that when the author picks the ingredients for their new recipe, you'll have a dropdown, so you'll do a select star from ingredients, and you'll populate that, or you'll create that HTML right there with the value equals the ID, and then you show the actual name of the ingredient. So what we'll do in a document database is instead of having the ID and the value, we'll just use the value, the ingredient as the value, as well as the label. So we'll create this collection that will contain all of our ingredients. So in this case, I've got my 2 ingredients, mushrooms and broccoli. And I just fetch all the information from that table and populate my dropdown just as I would with a relational database. All right, and another interesting thing that you can do, rather than having a bunch of different tables, if you wanted to create another dropdown for all of your measurements, for example, you could just add it into the same collection. What's fun with document databases is that the schema is somewhat flexible, so you can enforce it if you need to, but sometimes you might want to group things that are very similar together and just put them all together into their own into a one collection. So you've got one collection for all the data that goes into your dropdowns, and you can kind of mix that. In this case, the information has, well, exactly the same schema, but it could differ slightly, which is called the polymorphic pattern. So you've got to make sure that you're using fields that you can index, but the other fields can differ slightly. Now, of course, you don't want to add a list of movies with all of the actors that play in the movie into that same collection. Those are things that are completely different, so you don't want to mix those. But things that are somewhat similar, you can store them into that same collection. If you've got everything into that same collection, you can just create an index. In this case, I'm creating an index on the type as well as the value, and I can access all of the information or all of my ingredients or all of my measurements very, very quickly, and they're all together into their own table. So I can just do that fine afterwards and filter out only the ingredients in this case, or filter out only for the measurements if I want to. All right, but we still haven't solved the problem of the duplication of data, right? I've got that information into the collection of all my ingredients or all of the drop-down stuff, and I also have that same information duplicated in the recipes. Well, when it comes to duplication, well, first of all, we can think of that. Storage is cheap. It's very, very cheap. So we don't have to worry as much as we did in the 1960s about it. Developers are a lot more expensive than storage nowadays. So those document databases are a way to help you think of your data in a way that makes sense for you so that you can go faster developing those applications. But we still haven't fixed that issue. There's still this issue. What happens if we change the name of an ingredient? So I want to change mushrooms to button mushrooms because I want to make a distinction between 2 different types of mushrooms. So what happens? So I can do my update. So change my collection of all the ingredients. I can do a update 1, give it the value or the ID, and just update it. So I'm happy the information was updated, but now I've got all of those recipes that have that ingredient as well. So what we can do is simply do a second update call and update all of our recipes. You can do an update many, which will query all of the documents, and it's a much more effective way than to trying to find them individually. And you can just do that update command that you've got here. So I'm filtering for all of those that have mushrooms as part of the array of ingredients. If it does, then just update the value to button mushrooms. Sure, that's 2 calls. So I need to make those 2 calls. But Now this information is highly optimized for reads. And remember, I said I'm expecting this website to be extremely popular, to have millions of visitors every day. So I want to make sure that all of my data is optimized for reads. I want to make sure that when someone comes or a visitor comes to my website, I immediately fetch that data and serve it to them. So what I'm doing, instead of doing multiple read operations as you would do in SQL, well, it's not technically multiple reads, but doing those joins and finding the information across multiple tables, what I'm doing is that I'm grouping everything together so I can serve that very, very quickly, but I do that second call to make sure that I update the two collections when I need to update some data. So yes, a little bit more logic on the write side, a lot less logic on the read side. All right, so now I've got this application. I've got pretty much all the information here. And as you can see now, I can just do a find one. I give it the ID. I retrieve the full object. Everything is there at once. So much faster, much easier to access that data. I get instant data to all the information that I need for my page. So everything is there. If you paid attention and you were actually looking, you might have noticed there's this field that's missing. This one is a little bit tricky. So in here, I have the name of the author. So I've already said that we want to group all the information together because we want to make sure that it's very, very quick when we try to read the information. However, there's another section on my website where I'll have the chef profile. So I'll need to have a way to, I don't want to duplicate the whole chef profile in each one of the recipes, because that makes it really hard to query. Like, how do you find all of that profile information? That gets a little bit tricky. So of course, you can do joins in a document database. So exactly as you would in a relational database, in MongoDB, you can actually do joins, which is one of the things that I didn't know the first time I tried to use MongoDB. I hit a lot of issues because I was trying to embed everything into those huge documents. So you can actually split the data into multiple collections and then join it. So you can see here on the left side, you've got your collection for the authors, and on the right side, all the recipes. Now, I was talking about this talk to somebody yesterday, and I've realized that I was jumping straight into aggregation pipelines. And I realized not everybody might be aware of what the aggregation pipeline is in MongoDB. So I'll just take a small break to explain what the aggregations are in MongoDB. And please excuse me, earlier today, like in the speaker launch, I just grabbed a bunch of slides from like one of our marketing slide decks that explains what it is. All right, so this is what an aggregation looks like. So basically, an aggregation pipeline is used for any sort of operation when you try to perform complex querying operation, whether it's trying to join data from multiple tables, or if you want to group data or perform a series of stages on your data. The way it works is that you'll have a series of stages, and each stage will pipe the data into the next one. So you can start by doing, in this case, I think it's a match first. So we start by filtering down the data. Everything else is passed to the next stage. We're doing a group operation on that to count the number of records of something, I think so. So all of those stages are performed in order, as you can see here. Again, it's very different from building a SQL query. But as you'll see, to me, it's a little bit more intuitive to use when you get used to it. There's a lot of different functions that you can use as part of your aggregation pipelines. Things like the match, which will filter out the group that will help you to, group the information, or do counts. You can facet based on different buckets and different bucket sizes, and all kinds of things that you can perform with the aggregation pipelines. Actually, it's a Turing-complete language, so you can really do some really weird stuff with it. One of my colleagues built the game of life using aggregation pipelines, just like I don't know, he's one of those crazy scientists. So if, and I don't really like to compare, but so like if you're doing SQL, you're probably used to those, like those big joins, and you end up embedding things inside another, and those queries can become complex. If the aggregation pipelines look a little bit more like this, so it's a little bit more streamlined, and you've got this series of stages. So personally, I prefer to use those. And as you can see, like, it's a little bit cleaner. I find it cleaner. And there's a lot of tools that are there to help you build those aggregation pipelines. All right, so back to your regular programming. So joining data. So what we can do in order to join the information from our collection of authors and the collection of recipes is that we can simply add the author ID into our recipe document. So exactly as you would in a relational database. Once you've got those, you'll be able to do a search on the author database, or the author collection, and just map that into the document. So in order to do that, you'll use an aggregation pipeline. We'll use a $lookup stage, and using that is exactly the same thing as doing a join. So I'm telling it, find the information in the author collection that matches ID, author ID, and then just put all of that as the author field in my document. So that works, but now I've got to do that extra join. And again, I've got those millions of people coming to look at this page every day, so I want to make it a little bit simpler. And a great way to do that, which is probably my favorite pattern when we look at data in MongoDB, is the extended reference pattern. I find it very elegant by design. So I've got this page, I've got all the recipe information, I've got the name of the author here. So one thing I can do, instead of just putting the author ID, well, I can just put the author being an object, specify the ID if I need to find all of the information related to that author. But on top of that, I'll just add the name of the author. So now all of my information is part of my same document, and I don't need to do that aggregation pipeline. I can just do my find one again, and I retrieve all of the information again. So much quicker, one simple call, I fetch all of the data that I need, and I can use it immediately. So no need for those joins or computationally expensive operations. But again, we've got that duplication again, and we've got that inconsistency. And what happens if the author gets married and changes their name, or any life things can happen, and someone can change the name. So what we can do is exactly as we did earlier. So we just make sure that we update our author collection. Whenever we do so, we make sure that we update all of the recipes where the author ID matches that author. All right, so there's another thing on my chef's profile here, which is another very interesting pattern. I have this link that says, see all 5 recipes by the same chef. So one thing I can do, which in order to display this information is, again, go to the aggregation pipeline, perform that operation, make sure that I filter out all of the recipes by the author, and then do a count on that. So that will work. It will return me a document that says recipe count 5. So I can do my find to get the author profile, and then I do my aggregation pipeline call, and I've got the number of records. But we can also use the computed pattern, which is a very interesting pattern. And once you start using it, it comes very naturally. So what I can do here is that instead of counting the records, I can just add the number of recipes that I have as part of my author collection. And of course, we've got the same thing again. We've got to do 2 write operations in this time, but we'll be able to do a single read call in order to fetch that information. So now I can do my find one. I can retrieve the total number of recipes. And when I'll insert a new recipe or delete a recipe in my collection, what I'll do is that I'll add an update function. And in my update function, that's where I'll put in my aggregation pipeline that'll do that count. And I'll do a second stage that will do the $set operation, which will actually set the value of the total recipes field to what was calculated by the aggregation pipeline. So you don't need to actually do 2 different calls in order to count the recipes and then update the document. All of that is done through that single aggregation pipeline. And then we set it. So in general, when it comes to read-intensive applications, data access together should be stored together is kind of the way to think of your data. You want to make sure that you can access that data as quickly as you can and return it as fast as you can so that your database doesn't have to do all of that churn and try to do those joins and try to manage and access all of the different data spread across all of the database. So you want to make sure that you really optimize for that read and reduce the number of calls. So that all applies for read-intensive applications. But of course, sometimes you might have applications that need to be optimized for write as well. Most modern web applications are usually optimized for read. But you could have something that needs to be optimized for writing operations. So you'll have something that writes very, very quickly. Maybe I've got comments that people are commenting and like crazy. They love my recipes, and they just add so many comments. And at some point, I'll need to stop optimizing for read, because I know that people are always on the same page, but they're adding a ton of comments. So now you have to think about your data slightly differently. Normally, in the life cycle of an application, if you have to change from a read-intensive to a write-intensive application at some point, you're probably doing a full rewrite anyways, so it's very rare that you'll switch from one to the other. But there are different ways to optimize data for write as well. But again, it's always the same thing. You've got to make sure that the quickest operation is the one that you want to optimize for. So in the case of a write-intensive operation, you'll do simple writes. You'll try to avoid updates. Again, try to update an aggregation pipeline as part of the write operation. So doing that computed pattern would probably not be good in the case of a write-intensive application. However, when it comes to read, then it doesn't really matter. Maybe you've got an analyst looking at all of the data once a month, and even if his queries for Power BI would take a couple of hundred of milliseconds, that's perfectly acceptable. So in that case, you can kind of optimize mostly for read so that most of your users have a great experience, but that the people that access the data, and because it's not done that very often, they probably won't even notice the latency. But if you had a latency on every single one of the operations that you do for your millions of users, then it starts to add up. All right, what about relationships? So I've talked a lot about how to model. The big thing that confused me when I started to use MongoDB is that I was always thinking of my data in terms of their relationship and how to model that data. So I'll go quickly on kind of most of the styles of relationships that we've got. So one-to-one relationship. Say I want to add another table that will have like the difficulty level of the recipe, so beginner, advanced. So I can do a one-to-one relationship here. That wouldn't be a one-to-one, that would be a one-to-many. Yeah, anyways. So in MongoDB, what you would do is that you just add another key value pair to the document, and then you're done. So that's all you need to do here. All right, but what we typically have are one-to-something. So I'll look at it from a couple of different perspectives. Let's start to think about just a few documents that relate to the other, or a few data entities that relate to the original one. We had an example of that in the set of instructions in our application. So what I did here is that I just embedded all of the document, and that solves that issue. Again, because each one of those instructions are related to that object and only that object, and I'll never have to reuse them, it makes perfect sense to embed all of that information in there. And because it's an array, I can put in as much as I want, or as little as I want, and it doesn't have to be the same number across all of my recipes, unlike columns in a SQL database. So one-to-few, usually embedding is the way to go. Now you've got one-to-many. One-to-many is very similar again, but you might run into issues at some point. So I actually talked about that one, especially when it comes to data that you want to store in different places for some reasons. But you still want to be able to join them. So we've talked about those. Those are done through referencing. That makes perfect sense again. You want to access the authors on their own. You want to access the recipes on their own. So you want them separated, and you can do that join operation. Again, there are patterns to try to make it easier and faster to optimize for this type of operation. But typically, you would just use some sort of a dollar lookup here. Now, there's also one-to-a-lot, and I'm thinking like a very, very large number, like a bazillion, gazillion number. So one-to-a-lot. So say I've got this collection of recipes. Again, I've got my collection of comments, and people are going crazy. And I've got my, you can see here on the left side, I've got my array of comments, and I just do a reference for each one of those comments. So now my site is getting very, very popular. I've got some famous authors writing on it, and people are commenting. Like, there's a lot of people putting a lot of comments, and at some point, I'll get like an infinite number of comments. I won't know, I don't know how many comments I'll have. And that'll cause a problem at some point. There's a limit on 16 megabytes per document in MongoDB. And you probably never should be anywhere close to 16 megabytes in a single document. So if you don't know how many comments, in this case, that you can have, you'll want to make sure that you limit that a little bit. One way to do that is just to, again, change a little bit how you're thinking. So instead of putting that list of comments inside the recipe object, just move everything inside the comments. So each one of the comments will have a recipe, and you'll be able to still do that relationship. So you'll be able to fetch all of the comments related to a specific recipe. And now I can remove the array the unbound array that is there. So kind of reverse referencing is how you'll start to think on how to create those relationships. This is also great when you've got some of those write-intensive applications. This is the type of pattern that you would use. All right, and then we've got many-to-many, which is also, we've covered that one very quickly with the ingredients table. So what I do here is my ingredients, but maybe I want to keep that information separated for some reason. Maybe I want to keep an inventory or something of all of my ingredients. So I want to have them in their own collection, and I want my recipes in another collection. So one thing I can do here is to just use a two-way referencing. So you can see that in my recipe, I do have that array. It's not an unbound array. I know that there's a finite number of ingredients that'll go into a recipe. So I can add all of those in there. In this case, I'm just using the ID. You could use the extended pattern, which would make it easy or faster for read operations as well. But what I also do is that I have the array of recipes that are using that ingredient as well. So based on that, I can actually query the ingredients and find all of the other recipes that use this ingredient. I saw a question. Like, you're lucky because you're literally the only person I can see in that area. Can a database enforce the data key? Yes and no. So there are ways to do it. So you could use some triggers to make sure that this happens all the time. As part of the schema validation, I want to say maybe, but I really can't give you a definite answer there. So, and if anyone else has a question, well, I'll take. Oh, there's one there. When the comments become too long and too big, do you split them? That's also a very good question. Well, in this case, the comments, I kind of know that they shouldn't be reaching 16 megabytes. If they are that long, I'd be looking at a different pattern. So there are ways to do extended referencing. There's a couple of, at the end of this presentation, I'll share one QR code that you can look at, and it links to a blog post that has like all of the major patterns that are used, and there's a lot of very, very valuable information. A good example of that is Twitter, for example, where you've got, like, you could store all of the profile information of a user inside of a document, and then you would have a list of followers. And as much as I like to think of myself that I'm very, very popular, I don't have that many followers that I'll bust that 16 megabytes. But there are people who are much more famous than me, and they will have a huge number. So you'll want to split that into different documents. So there are ways and there are patterns that you can use to do exactly that. Any other questions? All right. Oh, there's one there. When do I think we should switch? You know what, let me just finish this, and I'll come back to that. Because, yeah, let me get back to that. I'll just go through this. I'm almost done with the relationships. So two-way referencing. I just want to leave you with a couple of tips, and then I'll answer your question, hopefully. So a couple of tips to think when you're modeling data in MongoDB. So again, there's this. thing with SQL, which to me was very easy and very comfortable. It's like an old pair of underwear. You know, it's just like, it's not perfect, has holes in it, but I like them. So it's very easy, and it was very easy for my mind to think of data in that way. And I struggled a little bit when I started using it. But looking at those tips really helped me to think of my data slightly differently. And like I said, now I find that it provides me with a better developer experience, because I can fetch all of my information in one shot, as I'm showing you. Anyways, let me just go through those tips. First one, always try to favor embedding unless there is a good reason not to. So always try to go or lean towards embedding data. But sometimes you'll have reason not to. And needing to access an object on its own is usually a very good reason not to embed that data. So our example with the chefs, we could embed the whole object, but that doesn't make sense. Like, we don't need that whole object embedded in it every time. And we want to make sure we've got access to this whole object on its own and be able to query for those specific chefs. Next up, avoid joins and dollar lookups if you can. So again, those are somewhat expensive operations, so you want to avoid them and reduce them if you can. But if it helps to provide a better schema, then use them. Like, there's nothing wrong about using them, but if you can avoid them, then you should. And then we've got arrays should never grow without bounds. So we've covered that one as well. You want to make sure that you don't hit that 16 megabyte limits. So you'll want to split data when you know it's going to be too big. And how you model your data depends on your application's data access pattern. That's very important. When you think of how you're going to model your data, you really have to think about how is that data accessed? Is it write operations? Is it read operation? How is the information stored together? And that's when you'll have to, that's how you'll have to think before you start modeling your data. So in summary, document databases, I like to think them as an evolution of relational databases. They're not something completely different, and they totally apply to relational data as well. It's just an evolution of it and a different way of thinking of your data. Design a schema that will work for your application. So optimize for your application and for your developers. Again, developers cost a lot more money than data storage, so optimize for that as well. All data is relational. Just use a pattern that works for you or your application. Data accessed together should be stored together. When it comes to read, that's the way I like to think about it and try to use my data. And those 5 tips that I gave, again, all of that will be available at the end on this link. If you're interested, you can go and fetch more information. The slides are available there. And then there's a couple of references, namely the blog post by one of my colleagues, which is amazing, that I provide the link in here. So I'll leave that one up. And I'll come back. I'll answer your question before I open it up for a full Q&A. So when should you switch from a relational database to a document database? Switching is hard. So if you're hitting issues where you just can't scale your machines at some point, you've added as much RAM as you can add, or as many CPUs as you can, and your machine still won't be able to provide you with that information, you might want, or you might need to migrate to another database type. So maybe a document database would be a good one. I'd say give it a try and start with a new project using a document database. And there is no case really where you absolutely need a SQL database or a document database. Like, they're both very complementary, or interchangeable. So you can definitely use them. Give it a try. Like I said, I think it provides a better developer experience. I love to be able to think of the data in the way I use it in my application. So I've got this website that I've shown you, and I've got all of my recipe object. I'm dealing with a JSON object to use in React and display all of that information into my components. And then I just fetch that object straight from the database and just use it directly. So I don't need to think about doing all of those joins and making sure to, when I need to update and then delete all of the ingredients from my many relationships. Like, there's a lot of thinking, and if you're used to it, it's fine. Like, you can do it. But when you don't have to do it anymore, all of a sudden it makes a lot of sense to use a document database. With that, I know I'm the last talk today before the movie. I will let you all go and take Q&A on a one-to-one basis. So if you have any questions, come and talk to me. I'll stick around for a couple of minutes. Thank you so much.